with the first problem. Again, I say again, because this is my second attempt at it. First time I didn't have the microphone going. So, try to go through this slowly so we don't miss anything. First of all, this is the 25-minute question. This is exactly what you should expect for the 2020 AP Physics C exam. Probably very similar to the AP Physics 1 exam in that there's a whole lot of explaining. So you got to know your physics concepts, but not a whole lot of math. So let's dig in. We have a student analyzing the section of a roller coaster track as shown above. Track has two segments, point A and B. We got the top half of a parabola from A to B, and then from B to D we have a bottom part of a circle. The car is filled with two sets of wheels, so the car cannot lose contact with the track. Why is that important? Because that tells us there's a normal force all throughout that track. Assume that any effects of friction and air resistance can be ignored. Don't skip that last sentence, otherwise you'll be in some pain. Alright, so part A, state the direction of acceleration at point A. Alright, so at point A, it says state the direction. I'm going to draw it. Acceleration. So we have the force of gravity and we have the normal force. So that means the total or the net acceleration here is going to be down and to the right. So I would phrase this at A, down and right. At point D, free body diagram, we have FG, and then we have a much greater normal force. So the net acceleration is going to be pointed up. How do I know it's a much greater normal force? Well, that's because I know part D is the bottom part of a circle, and there is always a net force directed inward towards this circle, and we call that a centripetal force, right? Remember that? So then I would say at D, straight up. Don't even have to put straight up. Just put up toward center of circle. Those are some easy points. Please get those. All it is basically putting your free body diagrams into words. You could even draw on there, so you know what's happening. Okay, but because it says state the direction, it's important that you understand what the question is asking you. It's not saying draw or sketch a free body diagram, it's saying state the direction, so that's why we had to put it into words. Okay. Part B, state the forces acting on the roller coaster at point C. So at point C, we know we have we know we have FG going down, and then we have FN directed towards the center of the circle. So, because it says state, FG is down, FN directed toward center of circle. Boom. More easy points, right? Moving on to C, the student determines the car takes 10 seconds to go from rest from point A to D. So the distance from A to B is 100. The distance from B to D is also 100. So what that's telling us is from here to here is 100 meters, and then from here to here is 100 meters. And each of those segments takes 5 seconds. The student hasn't taken AP Physics, doesn't know how to solve the problem. Instead, they suggest that x is traveled by the car that can be modeled by the function x as a function of t equals 6t. Look, whenever you have a variable that's given to you as a function of something else, and there's like weird exponents going on, minus 0.4t cubed. This needs to be a red flag, and hopefully by now it is. Calculus. Calculus soon. Okay, so we got to use calculus at some point, somehow, to deal with that. Maybe it's here, maybe it's not. Let's go on. Where x is meters, cars traveled past point A, t seconds. In the next questions, you'll be asked to evaluate. Oh, I'm reading ahead. Right? Oh, I didn't put the question for C. Explain how the graph could correctly model the motion during the first 5 seconds. All right, so we're only looking at this point here. And rule number 1 for swimming pool fun is look at your axes. Okay, we're looking at a distance versus time graph. So here to here. And it starts out at 0, and then it curves upward. That curve in a distance versus time graph tells us that our velocity is increasing. V is increasing. So how is this graph correct? Well, I would say it starts at rest. Right? It's kind of flat right here. It's at rest at the 0. Then speeds up. So graph curves. That's it. I wouldn't put anything more than that. Keep it at that. Keep it nice and simple. Even though there's a 10,000 word limit, don't feel like you need to fill the box. Okay. Part D, the second student disagrees with the model. Identify features in the model that are inconsistent with the behavior a car would have on this track. So as we're going from A to B, we're expecting our velocity to increase, right? We're going down a hill. So we're covering more distance as time goes on. Well, here we're going down an even steeper hill. So our velocity should be increasing even more. Right? But that's not what's happening in this graph. Instead, this graph looks like this, where it's kind of tapering off. So for the second 5 seconds, it's saying, oh, it's reaches max, and then that's it, right? It's going up and it reaches the maximum displacement that it's going to get to, and then that's all it's got. That's not what's happening. This is representative of what a velocity versus time graph would look like for this portion of the track from B to D. Okay, and that's not what's happening. So what's the question asking us for? The question's asking us to explain what's wrong with the model. I would say the speed should increase at a faster rate. So there would be a steeper slope, something like that, to indicate that you know what's happening and you know that it's a velocity versus time graph. It's not, or excuse me, it's a position versus time graph, not a velocity versus time graph. Okay, on to E. Now suppose the students obtain the correct definition function xt. Explain how the students can determine the height at different points. Okay, so Clue number 1, we're dealing with a roller coaster. Clue number 2, it mentions a height or height difference. Clue number 3, it's x as a function of t. We know some definitions that use x as a function of t. One of them is v dx dt, where if we take the derivative of our x function, that will give us our velocity. Okay, so and then we can plug in whatever time that it is we're looking for. So we have a velocity and we have a height. Velocity and height together. Energy concepts. That's your big clue. Go to your energy concepts. Okay, it's easier than your kinematics, and will save you time, and it's fun. Not so hard. All right, so here's what I would say. Explain how the students. So I need to give these students a procedure on how to. Well, first, or I'm not going to spell first. I'm going to put a bullet point because this is a time test. I've only got 25 minutes. Bullet point, I would say, take derivative of x as a function of t. Use t equals 10 seconds to find v max, maximum speed, the speed at the very bottom, right? And then I would use conservation of energy to find delta H. And I can use that because no non-conservative forces. There's no friction, there's no air resistance. It told us that in the problem. No non-conservative, I can't write on that part, non-conservative forces. There's all of your points right there. However many points should be assigned. Let me check the answers here, make sure. Let's see, so for H, yep, that's it, that's all you gotta do. I hope I'm not making this seem simpler than it is. I hope for you that it is seemingly simple. It's a lot to take into consideration, and you've been out of school for, I don't know, what's it been, 3 months now? So, just review. Let's go on to F. Explain how the student can determine the force that the track exerts at point D. We already talked about that, right? We already know that at point D, we have Fg and we have a much greater Fn. Well, we know that our net force, stuff that makes it go minus the stuff holding it back, because this is acting like a circle at this point, we're going to call that our centripetal force. Okay? So, the stuff that makes it go minus stuff holding it back, what's our positive, what's our negative? It doesn't matter. Let's take down to be positive or down to be negative, whatever. I think most of you will take up to be positive, down to be negative, so let's go with that. So we have Fn minus Fg. So we have to take Fg, add Fg to each side, and we have our net force equals, or excuse me, our normal force equals our net force plus Fg. And in this instance, all of this stuff right here, that's normally what we would say, but which is correct. It's just I don't want to confuse things by using net twice in two different instances. So our normal force is, you can go away, our net force plus our force of gravity. And in this case, our normal force, remember, is the one directed upwards, so that equals our centripetal force. So if we needed to go further, then we could say our centripetal force equals F net. Now this is not needed. This is just for review purposes. That's a G right there. And then mv squared over r equals F net plus Fg. Okay, so you can take this even further. Chances are you're probably not going to need to, because of the time limit and the digitalness of this exam. Okay, so this is your answer right here. This is what gets you your points. That's it for this problem. Hopefully it's not too difficult. Watch this a couple times, try it by yourself. Again, rework these problems even after you watch the video solutions, even after you know what's going to happen. Do these problems again, over and over again. That repetition is going to pay off, I promise.